Good morning, students. Today we are going to learn about revisiting rational numbers and their decimal expansion. This is a subtopic of the real numbers. So we already studied what are the rational numbers in the ninth class. So what are rational numbers? Rational numbers which are in the form of p by q, where p comma q belongs to z. Z means integers. In the p by q form, p comma q integers. Q is not equal to 0. Examples 1 by 2, 2 by 3, minus 5 by 6, etc. They are examples for rational numbers. We already know that. But if you see the decimal expansion, rational numbers are two types. One is terminating and other one is non-terminating. See, I will write here terminating decimal expansion. Other one is non-terminating decimal expansion. So mainly there are two types. Now we will discuss about what are the terminating decimal expansion type numbers. Let us take one example here. Let us take one example. For example, 0.375. 0.375. So this is a terminating decimal expansion of real number, of a rational number. So this is one kind of rational number which is in the terminating form. So this number can we convert into p by q form? Yes. How can we convert? That we can write as 375 by 100. Why? Because after decimal point we have 3 digits. That's why if we remove the decimal point we will get 375. Denominator we will get 3 zeros. Since after decimal point we have 3 digits. 375 by 1000. That we can write it as 375 by, that is 10 cube. Is it right? Now see one more example. Let us take the second example, 0.104. See this number also can write as 104 by how much? 100. So 104 by 1000. That is 104 by 10 cube. Now I am taking one more example, 0.0875. This is also I can write as, if you remove the decimal point, so 0875 by 1 after decimal there are 4 zeros. That's why we will write 4 zeros. So before starting with 0 there is no validity, so that 875 by, that is 10,000, that is we can write as 875 by 10 power 4. So these are the some uh, decimal numbers which are in the terminating form. So these are the terminating decimal expansion type numbers. Terminating decimal expansion. These rational numbers we are converted into p by q form. Yes or no? These numbers we convert into p by q form. So observe that, what do you understand, that in the denominator we can see that 10 cube here, 10 cube here, 10 4 4. So that every terminating decimal, if we convert into p by q form, we can get in denominator in the form of 10 powers. In power of 10 powers we get. For every terminating decimal, we can convert into 10 power of something. This is one property. And one more property, actually this 375 by 10 cube is not in the simplest form. Otherwise the p comma q are not suppose co-primes. How they will become co-primes? If you write into more, if you cancel it more simpler, if you cancel the common factors, we will get the simplest form. For example, 375 I can write as 3 into 5 cube divided by 10 cube. I can write as 10 means 2 into 5. That's why 2 cube into 5 cube. So I can cancel 5 cube and 5 cube. Then I can get 3 by 2 cube. 3 by 2 cube. Now here also 104 by 10 cube. So this is also we can convert into p by q form, such that both numbers should be in the simplest form. Otherwise they should be the co-primes. So how to write? So 104 we can convert into simplest form means, see that this is 13 into 2 cube divided by, this is 2 cube into 5 cube. 2 cube and 5 cube. Now here 2 cube and 2 cube cancel. That is 13 by 5 cube. This is also 875 by 104 is there. This is also we can convert into more simplest form. So 875, how can we convert it to, that is also we can convert. If we after cancellation, you can see that, see this, here 875 by 104 you can write, that is 5 cube into 5 cube into, that is you can write 7, 5 cube into 7. Now you can write here one more, that is what, 10 power 4 means 2 into 5 whole power 4, that means 2 power 4 into 5 power 4. Now here 5 power 3 and 5 power 7. How can you cancel here? See that 5 cube and 5 power 4. So 5 cube and 5 power 4. Here 5 cube 5 cube common, so that 5 cube cancel. So in the numerator we can see the only 7. 7 by 2 power 4. Here 5 cube once, 5 cube once after cancellation we will get only 5. So that here 5. So that the answer will be 7 by 2 power 4 into 5. Now see that these numbers, these decimal expansions we are converted into P by Q form. Next we have converted these numbers in the more simplest form. That means here P comma Q are in the P by Q form such that they are co-primes. If we convert into co-primes, that is what do you understand that? That means again you see the denominators here 2 cube, here 5 cube, here 2 power 4 into 5. So these numbers, what do you observe? In the denominator we can see either 2 power or 5 power or 2 power into 5 power. So this is one more property we observe that. That means what do you understand finally means a terminating decimal expansion, a rational number which is in the form of terminating decimal expansion, so that if we convert into P by Q form, so that a P comma Q are co-primes, then we can observe that in denominator they have only either 2 powers or 5 powers. The denominator should contains the factors as 2 power or 5 power. Otherwise we can say that the denominator either in the form of 2 power n into 5 power m. These powers only, either 2 powers or 5 powers. Where m comma m belongs to z, means positive integers. And this is one property, we observe that. And what you can say the converse of this statement, suppose a rational number which is in the form of P by Q, whose denominator having the factors as 2 and 5, a denominator having the factors as 2 powers and 5 powers, such that the P comma Q are should be the co-primes, then we can convert this fraction into the terminating decimal. That is the second property. So converse of the statement. First theorem, first what is the statement? First, a terminating decimal expansion we can convert into P by Q form, where P comma Q are co-primes, such that we can observe the denominator should contains only either 2 powers or 5 powers or 2 into 5, only 2 or 5, either 2 power 5, either 2 powers or 5 powers. We can see the denominators either 2 powers or 5 powers or both the combination. That is the statement. If you see the converse of the statement, a number which is a rational number which is in the form of P by Q, whose denominators having the factors only 2 and 5, we can convert into terminating decimal. That is the statement. So whatever we learn up to now about the terminating decimals, there is a theorem about the terminating decimals. What is that theorem? So here see that theorem 1.5, what is telling us here? What is theorem 1.5? Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of P by Q, where P comma Q are co-primes, and the prime factorization of Q is in the form of 2 power n into 5 power m, where n comma m are non-negative integers. That is it. So what you will learn up to now, that is converted into theorem. That is only theorem 1.5. See, what is that? Let x be a rational number whose decimal expansion terminates. So this is example of the terminating decimal expansion. Then what happens? If you express in the form of P by Q, I express it in the form of P by Q, that is like 3 by 2 cube. Then what happens? the prime factorization of q means denominator. What happens? We can see it in the form of 2 power n into 5 power n. That means in denominator we can write either 2 powers or 5 powers. What is the converse of the statement? See that. What is the converse statement? That is theorem 1.6. What is theorem 1.6 is telling? See that let x equal to p by q be a rational number such that the prime factorization of q is of the form 2 power n into 5 power m, where n comma m are non-negative integers, then x has a decimal expansion which terminates. So this is converse. So here beginning they are taking as a rational number. In the previous theorem, it is taking beginning as terminating decimal. Now here x is taking as a rational number such that which is now of p by q. First they are not taking as decimal expansion. They are taking as a p by q form such that p comma q are what? Co-primes. And here here co-primes not compulsory, but here see that the factorization. If you see the factorization of the q, suppose 2 power into 5 power m, then where m comma n are non-negative integers, then x has a decimal expansion so that it terminates. This is the theorem 1.6, which is the first theorem, converse of the first theorem 1.5. Now we will discuss about the rational number of the second type. What are that? That numbers which are in the p by q form, but they are not terminating decimals. They are non-terminating and recurring decimals. Suppose, let us take a number 1 by 3, 2 by 7 and 4 by 11. These are the rational numbers, and what will happen if you convert into decimal form? So what happened? See that just now we have understand about theorem 1.5, 1.6. From that theorem, we understand that a number which is in the p by q form, suppose p and q are co-primes, and if you observe the in denominator having either 2 power or 5 power, then it must be a terminating decimals. But if you see that these three are rational numbers and also a co-primes, 1 and 3 are co-primes, 2 and 7 co-primes, 4 by 11 also co-primes. But if you observe in the denominator, see denominator is 3, denominator is 7, here 4, but they are not in the form of 2 power n into 5 power m. That means they are not having prime factors as 2 and 5 in denominator. Suppose they are in the form of 2 power n into 5 power m, we can say that they are that fractions will be terminating type decimals. But here they are not in the form of 2 power n, 5 power n, so that they are not terminating decimals. Then what kind of decimals will get? See that if I wrote here 1 by 3 in decimal form, what I can get 0.333 and so on. If I write 2 by 7 in the decimal form, then what I can get it? Then I can get 0.285714, again 285714 and so on. Again, if I write 11 by 4 in the decimal form, then I can get 0.363636 and so on. Now here some group of numbers are repeating. So that first we understand that they are not terminating decimals. Then they are recurring decimals. Recurring means repeating decimals. So here 3 is repeating. Here 285714. Here 6 numbers are repeating. Here how many are repeating? 2 numbers are repeating. So we understand that they are non-terminating and non-recurring decimals. Otherwise non-terminating recurring decimals. So if you what we discussed up to now, if you write into statement form, that the statement is nothing but the theorem 1.7. What is theorem 1.7 is telling that let x equal to p by q a number in the p by where p comma q are co-primes, and it is a rational number p comma q are co-primes as like we taken as examples for this, such that the prime factorization of q is not in the form of 2 power n into 5 power. See that this is also not in the form of 2 power n 5 power. Here 3, 7 and 11 are not in the form of 2 power n into 5 power. Then what happens? That means here mn are non-negative integers, okay. Then x has a decimal expansion which is non-terminating. So which is non-terminating. That is the statement. That is nothing but theorem 1.7. So finally I will conclude that a rational number which is in the form of p by q, where p comma q are integers. Suppose in its denominator, a denominator if you convert into factorization, the factors do not in the form of 2 power into 5 power m, then such kind of decimal expansion is not terminating and repeating.